there is a ton more approaches or variants of the approaches that we have discussed. You can think of all different kinds of optimizations and trying things in a different order, or trying to optimize at this point or at that point, and some will lead to more computation time, some will lead to smaller circuits, usually not both at the same time, because if you find something that does both at the same time, we'd be very interested in it. A whole lot of things. So this should have given you a basic idea of how this can be done and of the best choices that we know of so far. And that basically only leaves me to summarize. So what have we seen? We have seen how we can transform strategy relations into concrete deterministic functions, which can then easily be transformed into propositional combinational circuits. We have looked mostly at symbolic algorithms because the explicit representations would be way too large to deal with. And our main goal was to kind of find small functions, small circuits, so we wanted to use this freedom that we have there in a wise way. As an important simplification, we have said that we will only look at one output after the other and perform resubstitution after each output has been computed to avoid running into errors. And then we have looked at 3 different approaches, namely a cofactor-based approach, which is very easy to be implemented if you already have a BDD package available, and it still has many optimizations left depending on where you compute reachable states, how often you do that, if you optimize variables, stuff like that. We've looked at the learning-based approach and at an interpolation-based approach. And that's basically how you come from strategies to circuits. So here's a list of the references that are used throughout the slides. If you want to look at any of these things in more detail, or you can of course also always come and ask questions. Otherwise, thank you very much for your attention.